Welcome to session 602, the encoding process in depth. And the way we're going to work this session today is we actually have three different speakers. The first speaker is going to be Doug Werner, who's a manager on our Apple.com team, who is known most famously for his amazing looking movie trailers. So he's going to talk about his process of actually creating those HD trailers that we have up on our page. Then we're going to hand it off to Nate Kaplan and John McClintock from the American Electric Power Company, who are going to talk about how to build out a distributed encoding render farm using compressors. So, going from just doing one encode to doing a whole batch of them. And then finally, we're going to end with David Singer, who's on our QuickTime engineering team, who's going to talk about H.264 from an Apple device perspective and how you can create content that is compatible with Apple's devices and what we're doing to make that a little bit easier. So with that, I'm going to hand it over to Doug.
Good afternoon. Thank you for coming and seeing us today. What I'm going to do is literally take you through what I'm going to do to start the encoding of a movie trailer that we're going to put up on the site probably tomorrow. If you get to the project, there we go. This is our new site. This is what we've been working on for a little while prior to WWDC. We changed the format of the trailer site a little bit, and hopefully people will appreciate the things that we've added, including a specific section for HD and such. So that said, we will get that out of the way, get this out of the way. And I've connected to my machine actually in one of my labs at Apple via Timbuktu. And this is the compressor app running. And on my right side here, which you may be familiar with if you are used to running compressor, this is your column over here that allows you to set your custom settings if you're not using the presets that come with the app. So I tend to roll my own, as they say. Let me close you. Anyway, let's scroll down. So what I'm going to do is I'm going to go ahead and grab a file here. And the file we're going to use is from New Line Cinema's Golden Compass, which we, like I said, will be posting on the site shortly. I've brought it into the app, and with my preset settings here, I have folders that already contain a set of HD resolution files at 1080, 720, and 480p. And I'm going to bring those onto the app. Now, when I'm doing encoding and after I've done a capture, our captures come in. Now mostly they come in on D5. So I have a D5 deck. I have two RAIDs that are connected, as well as the encoding machines are connected all by fiber. And my shorthand when I'm doing the encoding is to try and label what it is as I'm going along. So in this particular case, this clip is a teaser. My shorthand for 235 is that part here. 6 channel is the number of channels that are in it, and R is a ref movie. In another folder, I actually have the source movie, which has all 8 tracks, because when they come into me, most of the time they'll have left, right, surround, sub, and all that. And then typically they'll have 2 channels of dedicated stereo. And since QuickTime has the ability to do surround sound, of course, we want to take advantage of that. So I note in the file so that I can, having captured this actually last week, I can quickly look at this and know which set of settings I should jump onto it or apply to it. So what I've done is taken this folder of HD settings, brought them in, and this is my base set of settings. It's lagging a little bit. I'm not exactly sure why, but let me flip resolutions here and speed it up a tad. So the first thing I'm looking at right off the bat is to make sure that the crops are going to come in the right position, and then I'll go ahead and close that. In the settings, let's just take the 480p. I'll run through, just give you an idea of how the settings are laid out here for this specific size of movie. There we go. I think the button on my trackpad is sticking. That's why I'm getting a little bit of a delay. So running through it, I mean, often the most common question I've always been asked is, well, what settings do you use and all of that? So I'm just showing you for a 480p 235 trailer, in this case, what I'm going to start with is 2100 there, of course, frame reordering. And then in the audio, of course, we're going to be using AAC 5.1 surround, variable bitrate encoding. And I will typically kind of go to the middle of the road for the smaller files, and for the larger, like 1080p, kind of like your good, better, best, I'll definitely go to the highest setting for audio I can to support the surround. In this case, I have a very small amount of what I would qualify as image sharpening applied for the 480, since you're starting with 1080. I've noticed that it does require a bit of sharpening. And from what I worked on this past week, which I'll show you here in a moment, I used to run about a 50 on the details level, but I'm actually going to change it to 20 for this particular one, and I'm going to do the same to these. I don't think the 720 has any sharpening. I do have a slight bit of gamma correction, some brightness and contrast, not really all that much. I mean, the 264 encoder does a really good job of pretty much getting you where you want to be. And of course, the last panel here, I'm telling you what size I want it to be, and it's 235 is not true 16:9, so I'm compensating for that. And then the crops top and bottom. I do try and crop in at least divisible by 4. So let me do a save. And since I've shown you that process, I'm just going to hop down here to the other ones. And this would be 235, 2-channel HD5. And so this particular set has the lower resolution size of 640, 480. And this one is going to be one of my guinea pig files to convert for iPhone. Then I'm going to go over here and essentially, I'm just actually triple check to make sure that these other guys are definitely the correct batch, cropped correctly, so I can close that. Switch this to my cluster. And it's going to go ahead and take off. And it'll bring up the batch monitor, and then I'll switch this to this cluster server. And this tells us what we're doing. And right off the bat, you're going to see that the 4 machines that I have attached to my cluster have already started to encode these particular files, and I've got the other ones waiting. So in theory, most of these will be done by the time I get back. To give you a point of comparison, when I started doing encoding back around 99 and did things like the Star Wars trailer, it would take about, I think memory serves, it was about 12 hours to do one 480 encode. And at the time, once I got my lab really going and cranking, I had 8 machines all stacked in a pyramid in my office. And I would use one machine with one setting and one machine with a slightly different setting, and I'd be literally using them in parallel. And then I'd take them out and be like an eye test, say, okay, was this one's better or this one's better? And 12 hours at a whack, you want to try and get it going as promptly as you can. So that was the best hardware I could throw at it at the time. And now to look at it nowadays, you can see here that this 1080p version at 1920 by some odd is going to take probably about an hour and 10 minutes to do. So we've definitely come a long way. With compressor 3, you can allow a machine to have a virtual cluster. So I'm really looking forward to literally doubling the number of machines I have to be able to take advantage of the additional horsepower that it'll provide. So this is off and running. And the setting that you saw me change, let me just close this stuff, gets back to, where did they go? Let me pop to the web here real quick. And are we going? Yeah, we're going. Okay, here we go. I thought I had a couple sample files with me, but I'm going to go ahead and run down here to this guy. Oops, where did he go? What I was going to do, I may have to come back to at the end of the Q&A session. I thought I had a couple files with me. I was going to show you firsthand the difference, because when you're coding something and you run through it and you're looking at it, it still might look a little bit crunchy, and you think, oh, I might have to apply a little bit more data rate to it. What you can do is go back into that panel that I showed you previously about the percentage slider there and make a slight adjustment there, and it makes a difference in having, like, it qualifies less crunchiness in that space. So that was what I was going to show you. And essentially is it, was what I was going to provide. And like I said, during the QA session, I might be able to come back and show them side by side. I'll go get them. But I wanted to give you an example of my workflow. What I will do is get this guy back up here. After the files are encoded, they go to another machine that's actually in my office as opposed to the lab. And it's had the setting applied to it. I will annotate them using AppleScript by taking a set of them, for example, here. Oops, I'll just grab a couple. And I have specific studio scripts that I will drag them onto, and they already have all the factors preloaded. I think this one is Sony Pictures. And I would simply put in the name of the film. And what it's going to do to all of those is open them, apply the copyright information. Come back here. And then complete that step automatically without having to go in and individually annotate each film. And then I have another script that I run that creates multiple reference movies. And the purpose of that multiple reference movie for one file is once I put them up on the server, I can see if anybody is deep linking to the file directly, or if I'm sharing the files with multiple people, I can have, like a -A, -B, -C, and when I'm doing my reporting, I can run a report and say, oh, look at how many people are looking at this file via the web, as opposed to deep linking, as opposed to one I may have given to product support or to iTunes and that kind of thing. So I actually track, using AppleScript in multiple movies, the ability to keep track of how many iTunes people watched a trailer as opposed to showing the main website. And once I've created the reference movies, all they do are they're just pointers. There is no speed selection or anything like that. I'll just simply create a template file, which have the little guy on there, and then I'll just add it, throw it on top of this particular script. And it automatically creates all of those files, and then I'm ready to drag those up onto the server for tracking. The nice thing about this in terms of Compressor 3 is it has the ability now, instead of having to do that, you can annotate the source movie first, and then once you go through the compression and all the steps, it'll automatically pass that amount of information on to the other movie. So I'm really happy about that. The other thing that's new in Compressor is the ability to separately adjust volume control, because in my experience I've noticed that the audio level drops after the encoding takes place, and you can essentially overdrive it slightly during the encoding process so that when it comes back out, your level should be the same as where you started. So that concludes my particular segment of it. And of course I'll be here for Q&A, and hopefully if I get back up here and run around, I'll show you those two files that show you the comparison of what I was talking about, how to refine the encoding a little bit tighter. Oh, I did have them.
Clicker.
I am clickerless.
Yeah. Podium. Hi, I'm Nate Kaplan from American Electric Power in Columbus, Ohio. This will take us forward. Great. Okay, so we're here to talk a little bit about our workflow. American Electric Power is a company of about 20,000 employees spread across 11 states, and we use QuickTime extensively on our corporate intranet called AEP Now, which you're seeing the home page of right now. This is the home page for all AEP employees, their web browser, whenever they launch it up. We've integrated video into this site for training, for safety, for communication from executives to employees via live webcasts, etc. As you can see, there's a tab called AEP TV, and when you click that, you get to this page, which has our featured videos as well as a video library by categories here at the right. All of these are QuickTime videos, and this is all driven by a database back end. When you finally get to an actual video on the site, you see this large poster frame and a description, and if you click the Watch Video button, it'll launch up the QuickTime player. And it uses a QuickTime reference movie that detects the bandwidth using QuickTime 7's automatic bandwidth detection feature and feeds them a small or a large file depending on the bandwidth at their location. That's what it looks like to the users. Now let's talk about how we do this in our production workflow. We're going to talk about distributed encoding with XSAN and QuickTime publishing automation with AppleScript. So I'm going to walk you through building and using a managed QMaster cluster, which is what we do. I'm going to step you through each of the applications that are used in building a cluster, and then I'm going to turn it over to John McClintock, who is a streaming media developer on our team, to actually demonstrate to you how we automate our workflow. These are some of the Apple technologies we use. And this is our topography of our cluster. We have a so we have 7 workstations. One of them is John's personally, and the others are used by our video producers and our video manager. They're all Final Cut Pro video editing workstations that have the QMaster services on them. They're all connected together via both an Ethernet network and an XSAN fiber channel network with a shared SAN volume that they all use from right within Final Cut. So when they finish a file, they actually save it onto the SAN volume and let us know that it's ready to be encoded, and then the process that John will demo for you gets started. We do have one Xserve that acts as our QMaster services cluster controller machine that does little else in the network in addition to the other Xserves we have that are QuickTime streaming servers. So that the QuickTime streaming servers obviously are the ones that distribute the files on demand and live to our users throughout. Okay, so starting off in the QMaster System Preferences pane, under the Setup tab, to make a managed cluster, you have to go to each node on your cluster and turn on Services Only there at the top part, which I guess, do we have a... on the controller, you have to select Services and Cluster Controller together. Now, there's this option called Quick Cluster with Services, which is for making kind of ad hoc clusters, but we found that QMaster is more reliable and more rock solid if you use a managed cluster instead. In this pane, you can also set up a password so that the administrator must enter a password for each node that they'd like to add into their cluster. On the Advanced tab, this is a key thing for using an XSAN cluster. You have to set this setting here called cluster storage. You see there it's volumes, video, QMaster. Video is the name of the XSAN volume, and it's key that every node have the same exact path to the cluster storage, and that path must be somewhere on the XSAN volume for you to take advantage of the faster speed that you get with an XSAN. Because what actually happens is that instead of QMaster distributing pieces of the file, or actually the entire source file to every node before it begins encoding, all of the nodes begin encoding immediately on the same file that's already on the XSAN shared by all of them. The status option, to show that in the menu bar, it puts a little status icon at the top right corner of the person's screen that lets them know when their machine is being used for a cluster encoding job. This is important because if your nodes are actually production machines that people are using Final Cut or Motion, they may want to opt out so that their machine is not part of the cluster for a period of time that they're doing some intense job. So if they see that, it's a reminder they can go up there and open up the QMaster tab and turn it off. Q Administrator is an application that ships with Final Cut Studio. Once you've turned on QMaster services and all your nodes, you have to go to Q Administrator and create a new cluster and drag and drop the machines into it, which would appear at the bottom part of the window before it's been set up. After that, it's a simple matter of giving the cluster a name and applying your settings. Then inside of Compressor, right here, you have your settings set up just as you would any other setting that you're doing, like Doug was showing. The two key things you want to look for are this allow job segmenting, which is in each preset in Compressor. If you check that, what that allows Compressor to do is to divvy up a single file and send pieces of that source file to each of the nodes to work on, so that, say if you have a longer duration file, 10 minutes or more, that one file will get encoded a lot faster. If you don't check that box, the QMaster cluster will only speed up the encoding of multiple versions of the same output or multiple files. And then finally, when you submit the job, at the bottom left corner, you have to select the name of the cluster instead of this computer. Okay, so now I'm going to turn it over to John McClintock, who will demo this. If we can, oh, we don't need to switch to a demo machine. Just hit next.
Alrighty, I'm going to run through an example of our sort of default workflow when everything is going simple. And our editors, when they've completed a project, drop their files into a masters folder. And we're just dragging that into Compressor and selecting the file. We like to do this manually so that we can verify aspect ratio, make sure that the project will work well with our default settings. This one's a 16:9 project, so I'm just going to drag our a set of 16.9 settings onto the project. And I'm going to check a sort of before and after, and you can see there's a crop being applied and so forth. Then we will pretty much be able to select the cluster, which in our case is called a Newton cluster, and we'll submit the job. The batch monitor pops up, and the fact that the status says processing is a good thing. A bad thing is when it says waiting for long periods of time. Hitting the twirlies gives you some status of the segments. There is, as far as I know, no way to tell which segment belongs to which node. So if you're having a problem with a particular node, it's not always obvious which one. When the batch is complete, it dumps the files into a destination directory. And we do a little bit of extra processing using an Apple script afterwards. So I'm going to select the files in the destination directory, queue the selection of the files, and locate my droplet. And we just drag the files onto the application. And it's going to actually re-hint the movies because we need to do that. And it mounts the QuickTime servers if they're not already mounted, copies the re-hinted movies out to those servers and one into an archive directory. And right now it's building a reference movie. It builds XML and then makes a reference movie out of that, and then uses fetch to put it up to production. So this is the admin of our content management system. And it's pretty much active server pages, classic active server pages. And there's various fields that I've pre-populated. The critical thing is the file name, and we use file naming conventions so that they work on scripts throughout the entire production process. And those just are there's a file stem that is the name, which has a library number and so forth. And then there's an extension that tells us the size of the file and the aspect ratio. And all of that gets used in various scripts to populate the user end of things appropriately. And we're just sort of wandering around the screen. The users are able to download the video, which we find reduces DVD orders. They're able to order DVDs online. I've set this clip to not visible. It'll still run in the interface, but it doesn't show up in searches and it doesn't show up in category listings. So I sort of verify the settings in the admin, and then we'll go back to the admin screen and launch the chooser page that the video shows up on. And this is what the user will end up seeing. And we'll just click the watch video button eventually and verify that we do in fact have video. You may have noticed a little pop-up window that opened and closed. That's our stat tracker. And that gives us some statistics on hits for the video. So we do have picture and we have sound. So at least we know that the video is out there on the servers. Now, when we looking at the page, you see that sort of default graphic that has nothing to do with the video. So we want to populate the page with something that's related to the project. So using another Apple script, we select an appropriate frame, something that will sort of suggest the contents, and run another script out of the script menu. And that's going to export a still frame out of the video, open it in Photoshop with a preset crop, and there's some human intervention to sort of select where that goes. And then for our category listings, we use a small 65 pixel square thumbnail that that's made in the same script. So those are being saved out to the, and fetched up to the production servers. So we're going to just go back to the browser and refresh the page. And we should have pretty much ready for use and publication and so forth. So the QMaster cluster has been really very reliable for us in general, but it definitely does go down now and then. There are a couple things that are like absolutely necessary. One is that all the nodes have to be running the same version of QuickTime. They all have to be using the same XAN folder for cluster storage. The main reason for failure seems to be if one of the nodes has a hang for other reasons while it's crunching, the whole thing will go down. And what that looks like is in the batch monitor, the thing will be waiting. And usually by then you can identify that there's one node in particular that's waiting. Everything else, it might be 98% done. But anyway, it's easy to fix. You go to the cluster controller machine and go into its QMaster preferences, stop services, and it says 10 minutes. And you say, I'm no waiting, 0. And you stop the services. You're not going to recover them anyway. And then click Option Start Services. And this is sort of hidden. It took me a long time to figure out the option click method to reset services. And then start the services again. And then you need to go back into the Q administrator and rebuild the cluster, which is not a big deal. I mean, you just rename it and drag the nodes into the thing and so forth. So it's a very straightforward process. There's a line on software update here which is probably confusing. The key to software update is to not update any of your nodes ahead of the XAN. The XAN metadata controllers and so forth particularly need to be the last word. So you need to update everything else to match them. And you should do those all at once, pretty much. You don't want to have different software versions on different volumes of the whole thing. When the script is running, it's building reference movies. This is just a snippet of, we're selecting different protocols for different lengths of videos. We'd like to do progressive download. But it doesn't work well with long files, and being a corporation, we are able to produce amazingly long videos, and you don't want them progressively downloaded. So this little clip here is just saying that if the clip is less than 10 minutes, it's going to be progressively downloaded. It'll have its protocol set to HTTP. If it's longer than 10 minutes, its protocol is being set to RTSP. And
I might add that the same machines that run our QuickTime streaming server are also running web services with the same home directory. So one can access the same file by progressive download or RTSP streaming just by changing the stem, which is all this does.
Yeah, and this is just a snippet of how the XML text is being written. And here's what the XML actually looks like. And this XML is saved as using the file stem _ref.qtrm. And then the QTRM file is opened with Peter Hoddy's XML to ref movie, which is available at this website and is the only darn way I can think of to do this thing. But it works great. So what it'll make is a movie that will be called something like filestem _ref.mov, and then the script changes the name to a .qtl for maybe vestigial reasons. We used to be more concerned about hijacking of videos by particularly Winamp and Real Player occasionally glom things, but nothing gloms a QTL file. Not even Safari knows what to do with a QTL file. So we've had pretty good success, really, with our compressor QMaster experience.
Yeah, I mean, overall, it has really sped up our process. It used to be, we used to use Cleaner until about maybe a year and a half ago, and when one of our video producers would finish editing a project, they'd tell us it's ready to be encoded. If they gave us a file that was 5 or 10 minutes in duration, we'd say, well, we might be able to have it posted for you in 2 or 3 hours. You know, to grind out the couple of versions that we do, because we were doing it on one machine. And now a 5 or 10 minute file is we can have it posted in a matter of 10 or 15 minutes, because our cluster can crunch through it faster than real time, creating multiple versions. Moreover, we have a lot of these very long movies, 30 minutes, even an hour long, boring legal lectures or something. And these things used to take a day or two to encode, on a machine over a weekend, and now we can get them done in a matter of a couple of hours. So, like Doug said, compressors really helped out our workflow, and we're really looking forward to using Compressor 3, which we hope will take even better advantage of our multiple core workstations to speed it up even more. So thanks a lot. And we'll do questions after everyone. Oh, next, David Singer from Apple.
Hi, so now for a quick change of subject, slight change of subject perhaps. I'm going to try and deal with the question that we know a lot of you ask: how do I make a media file that will play on my friend's iPod, or that new iPhone, or the Apple TV, or the heads-up display in the new iCar? Did we announce the new iCar yet? So there's 2 basic ways that we establish suitability of a file, and you can look at a file to establish whether it's suitable for a particular usage. You can look at the movie atom in the file. The movie atom contains all the declarations of the file's structure, the codecs it uses, whether it's self-contained. You can work out how interleaved it is, and so on. And you can check to see whether this file actually conforms to some specification for, say, a particular device or whatever. So you can scan that. Alternatively, there's a way of signing a file. If you look in our files, you'll see there's a thing called a file type atom at the front of them. It has a list in it of what are called brands. Those brands claim that the file is conformant with a particular specification. So you can bypass the check for the movie atom by scanning it by just looking for a brand that asserts what you were hoping to find. And that makes life much faster, and obviously it's something we recommend. So these specifications, what do they look like? Well, there's going to be 2 basic classes of these specifications we'll be publishing. There's class-based specifications and device-specific specifications. Now, the class-based ones are fairly easy to understand. They're going to rely on publicly defined features of the file, so things that you can easily check, that rely on standards and documents you can pull down from Apple and from other places. So, for example, what codecs do you use? We don't process Cinepac on the iPod, for example, so that would be a bad codec to choose. The profiles and the levels of the codecs for MPEG codecs, for example. Do we do main profile on this device, or is it just baseline? What level do we go to, which tends to limit things like bit rate and screen size? What file format features are present? Is the file self-contained? That generally helps if you're going to put only the file on another device, because if it's self-contained, you've got the media as well. Is it interleaved? Is it in time order, and so on? Those are sometimes important to devices which don't have a lot of bandwidth to their storage. How fast, what's the bit rate of the file? How big can the file be? And so on. So specifications listing things that you can obviously work out pretty easily from looking at the file. And indeed, the class-based ones have unprotected and protected variants. Clearly, Apple devices tend to be able to play files that are protected with Apple's Fair Play system, but other devices can't. And in case you're looking at the files and you want to go, well, why don't I just slide along right behind Apple so I can use the same encodings that people are using for the iPhone, but just an unprotected version of it, then you can look for the tag that says, yeah, this is conforming to an unprotected file. And the class-based ones, we're hoping that they will be supported by 1 or more Apple devices over a period of time. So if you're building a library and you don't want to be re-encoding a library every time we come up with a new hip device, then maybe you want to be targeting a class-based specification in the hopes that we will continue to support that class in our new devices. So let's look at some example general classes here. Basic audio, something that will play on the iPod Shuffle and pretty well everything else. Yeah, something that's a portable audio-only file. low-resolution video, something that will play on the first generation iPod video, the one we're currently shipping, and the way we initially published it, the 320 by 240 size that's very portable, very standards-based. A basic spec for standard def video, extended video, and then probably a class also for desktop video, something that we don't actually restrict the bit rates and the file sizes, because our desktop machines, they're brave. They'll attack anything, even if they drop frames occasionally. Now let's contrast that with the device-specific specifications. This is where you realize that you want to make a file that works perfectly on just one device, on a specific device. And often this is because obviously you're stretching the limits of a device. So this is, the classic example of this is getting standard def video out of the iPod video. As I say, when we first launched the iPod video, we didn't actually try to do standard def video on it. We were doing 320 by 240 on it. We realized that we could in fact get standard def video out of it. But the recipe to get it is a little tricky. You have to tune the bit stream so that they just get through the decoding process on that. So this is the famous low complexity mode that we publish, that we don't actually tell you what it means, and we know that, and this is what I'm telling you today, is that we know that you don't know what it means, and we're going to tell you what it means. We are working on the documentation for it. And the UUID tag that you'll find documented in some sense, or at least mentioned on quite a lot of blogs and websites around the internet, that is indeed the embodiment of that claim, of that low complexity tag, seeing that UUID tag. That UUID tag is a bitstream tag. It claims that the bitstream respects the limits of and will play on a very particular device. Now, as I say, getting these things to work when you're stretching the limits of a device is sometimes a little So we will publish suggested ways that you can achieve this. We'll probably have to simplify. The real recipe may be as complicated as counting the number of motion vectors over a half-second interval and multiplying that by 1.3 and subtracting the number of 4x4 macro blocks, adding in the number of 8x8 macro blocks, dividing by the phase of the moon, and checking that doesn't exceed 237. Well, that's more than we're going to write in a specification. We'll write something that is actually comprehensible, we hope, but you, and indeed we, may experiment to establish what in fact works. If you can prove to yourself, to your own satisfaction, that your software writes files that actually do work on the iPod video, even though it doesn't quite follow the recipe we publish, then bully for you, that's great, go ahead. Now, the tag, the UUID tag that I just mentioned, you have to put that in the movie atom. But it's making a claim about the nature of the bitstream and the rest of the file, which, as I said at the beginning there, you notice we didn't look at the rest of the file when we were looking to see whether a file was suitable for a device. We're just looking at the movie atom and the tags and the brands in the file type atom. So the tag is a UUID atom, specific content in the sample description in the movie atom, saying something about the bitstream. So, summary. Let's see if we can go through this very carefully. The file tags, the brands, they assert and they confirm conformance. If you see that, you can go, man, the person who wrote this file claims that it conforms to this spec. I don't need to check. If you don't see the tag you wanted, the brand you wanted, the absence doesn't deny it. You're going to have to scan the movie atom to check. Why do we say this? Well, maybe the software that wrote this file wasn't aware of that specification. When the person wrote that software, maybe that specification wasn't available. So you want to grandfather files that will in fact work on a device if you can. So check to see whether the file will work. Now, you can have device-specific file tags, yeah? So a file tag will say the entire file has been tuned to work on this device. And you're only allowed to put that in if the matching bitstream tag is present in the movie atom, saying the bitstreams have been tuned for that device. So the presence of that bitstream tag claims playability on a particular device. But unlike the file level tags, the absence of that tag means that you cannot assume playability, and it's not easily checked either, because putting it in would mean that you would have to decode, say, the video and check that the number of 4x4 macro blocks multiplied by 1.3 minus the number of 8x8 macro blocks and divided by the phase of the moon does not in fact exceed 237 over a half-second interval. And you're not going to do that every time you want to put a file on an iPod or on an iPhone or something. Yeah? That involves scanning the entire file and basically running a decoder almost in debugging mode to check that limit. So if you can't see the bitstream tag, you give up. It clearly wasn't claiming to be compatible, so there's a good chance it's not in fact compatible. So, if your software creates files, if you are a software author and you're writing files out there, if you make a stream, obviously, to work on a specific device, then put in that bitstream tag, because nobody is going to put it in after the fact. Then, look at the movie atom and look at all the specifications your software is aware of, and put in the signatures of all the specifications that you are aware of, all the brands that correspond to those specifications that the file, in fact, does conform to. Yeah? This is trying to catch as many people as you can and giving them a fast in so that they see their specification and they go, okay, this file works on my device. I don't have to check any further. Now, please, 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 if you don't know what a tag means, a bitstream tag or a file level tag, if you don't know what it means, don't put it in the file. Yeah? You're making an unsubstantiated, probably false, misleading, and almost certainly unhelpful claim. You're claiming that you've checked that this file conforms to a specification you haven't even read. So please, people around the internet are suggesting on blogs, man, if you just copy this UUID atom into here, it seems to work. Well, it will work some of the time, of course, because by luck, you will hit some bit streams that do, in fact, conform to the limits. But you're telling your users or the people who are reading the blog that it'll work all the time, and that's probably not true. So if you're reading media files, flip it round. Look for the tags, the brands you support. If you see that, you're done. That's a quick check, yeah? You just have to do the checks of these 4-character codes, and if you find one that you support and the file conforms to that, you're in. We're done. Now, if none of them are present, then do the second level check. Scan the movie atom and look for what your device requires. Now, for Apple, that means that we may be looking for bitstream tags in the sample description if this file doesn't meet suitable class-based limits. Obviously, if it's an iPod video and you've put in simple video, the 320 by 240, we don't need to check for the bitstream tag because it's already a class that the iPod video supports. So, I'm sure you're going to want more information. We are going to publish details of the brands, the UUID tags, the low complexity modes, and how to make them. We're aware of the lack of that documentation, and we realize that you can see that we're doing something and we're not telling you what it is, and that some of you are trying to guess and trying to work around that. That's not a position that we like to be in. We will document this. We are working on it, and we're apologetic that we haven't done it so far. Ed Agabeg is your main contact, of course. If you have questions after the event, and he will find the right people and harass them to get the documentation you need. Then, coming up this week, if you're into encoding, you've got to go and see how to create integrated workflow solutions with Final Cut Pro, because that's the greatest tool out there, and that's the most fun you're going to have this week. Next after that, however, if you want to have fun mastering QuickTime digital video and creating effective, sophisticated podcasts. Don't create boring podcasts. Create effective, sophisticated podcasts. Come to Presidio on Friday. Likewise, there are labs here that we can help you with: digital video pre-processing, media encoding, and media delivery. And indeed, tomorrow, you could hit the QuickTime lab, the media and graphics lab, and find out about standards, where I'll be there, and you can come and ask me hard questions about international standards for multimedia.